Daniel, who's my favorite student? It's not you. Who is it? It's good old Ann Serkey. She gets everything right. I like number one. I like number one. I like number one. Mr. Dewick, it's on a quiz. Yes, and I'm still saying I like number one. I like number one. I like number one. That's a hint. There's going to be a question in your future about trains passing each other. They might be coming towards each other, or they might be going in the same direction. Okay? So how long? I guess this wants me to find time. Jet, do we have two objects moving at different speeds? Say yes. Are they moving near the speed of light? So we're not going to use any of the relativity stuff. This is a job for just relative speed. What we said was we're going to be using d equals vrel times t, and that comes out of the fact that a is 0, and then d equals vit plus a half at squared just becomes d equals vt. Which v? Well, there's two objects moving. We'll pretend one is at rest, and we'll use the relative speed. I guess then that means if they want me to find time, they gave me, or I can figure out vrel. Jet, what do you think the relative speed is? One's going 10, one's going 6. Is it 4 or 16? What's a good way to remember? Head-on collisions are worse. You add them together. Okay? If they're in the same direction, getting rear-ended is not as bad. You'll go bigger minus smaller. That's for speed. I don't think I'm going to ask you a velocity question on your test. I don't care about negative or positive. I just care about magnitude right now. So I agree with that. Now, the tricky part is the distance. Jet, my argument is for these trains to pass each other, the back of that train has to pass the back of that train. I think that's the distance that we're talking about. I think the distance is 120 plus 450 plus 80. I think that's the distance. What'd you get? No, sorry, for the distance.
Oh, I
didn't write it down on a quiz? Really, my friend? Always show your work on quizzes and tests. It's 120 plus 450 plus 80. I could do that in my head, I guess, because 120 plus 80 is 200. So 650. Is that correct? I hope. I did a quick check. Hopefully you're in the habit now, Chantel, as you're reading, you're scanning units and just making sure they're all good. At the beginning of last unit, I was always check the units. Is it kilometers? Is it meters? Now, hopefully that's built into you. So I did a check. The units are all good. I said they want me to find T. T is going to be D divided by vrel. It's going to be 650 divided by 16. Was Jet correct? I don't know. Let's see. Divided by 16. I got 40.6. Is that right? Yeah? Now, the problem is, if you didn't show your work, I can't give you as many part marks if you made a typo somewhere. Seconds, if you missed the seconds, I would take a half mark off. If you got that, I would give you 3 out of 3. Otherwise, I would probably give you 1 mark if I saw the 16 somewhere. Because to me, that's the key to doing this. I would give you a half mark if I saw the 650. I would give you a half mark if I saw that equation. I would give you a half mark if you got the T by itself, and a half mark for the answer. Okay. So in the future, you can expect either 2 trains coming towards each other or 2 trains going in the same direction. Did I do? Oh, I should have done one of those. I did. So how long? Now, I would also have no problem telling you the time and asking for the distance. Oh, then it would just be vrel times t. Or I would have no problem giving you the distance and the time and saying what's the relative speed between them, and then maybe saying, okay, if this one is 6, you would have to figure out that this one was 10. I don't think I did that on your test, but it would be a fair game. In other words, from now on, because I've taught you formula manipulation, Caden, if I show you how to do a question in one direction, I figure you can also reverse the procedure and figure out whatever you need to. That's part of why I spent so much time last unit getting you comfortable with rewriting equations. Same question, basically. It wants time. A is 0. Caden, what's the relative speed this time? I'll give you a hint. It's not 13 or 5. 8. And I guess the distance is going to be, well, again, for this train to pass the other train, the back of the first train has to get past the front of the next train. So the distance that they're going to travel relative to each other is going to be 150 plus 450 plus 100. I can probably do that in my head as well. Is it 700? D equals VREL times T. So T is going to be D over VREL. It's going to be 700 divided by 8. 700 divided by 8. And I get 87.5? Good. If you got 87.5 seconds, I would give you 3 out of 3. Otherwise, fairly similar. I would probably give you 1 whole mark if I saw the relative speed, because that's the key to being able to solve this question. I would probably give you a half mark for that. I would give you a half mark if I saw that. Half mark for that. And what am I at? 1, 2, and a half mark for the answer. There's my 3 marks. Now I think we're in special relativity. So it looks like they want me to find, I think they want me to find L. By the way, I would probably use a capital letter L. Why wouldn't you use a lowercase l for your L? What does that also look like? Looks like a 1, especially if you go like that. Looks like either I0 or 10. So capital L, and that's why we use capital L's in our notation. I think they want, because they're asking what length would the people on Earth who are stationed, and it says this is when the spaceship is stationary. I'm pretty sure that's L0. And it looks like V is going to be 0.96c. So L is going to be L0 times the square root of 1 minus V over C all squared. It's going to be 620 times the square root of 1 minus 0.96c over C all squared. Hey everyone, do you see? Do you see? Do you see? What do you see? So the C's cancel. 620 square root bracket 1 minus 0.96 squared, close bracket, and you get 173.6. Common mistake that I've seen kids go 620 times the square root, and they forget to put a bracket. My calculator won't let me not put a bracket there. It forces me to put the bracket. I can't even delete the bracket. But I've seen kids type the 1 minus 0.96 not in squared, not in brackets, and then all that happens is the calculator takes the square root of 1, not the square root of 1 minus 0.96 squared. So 173.6, if you said 174, that's fine. I've been going to a few extra sig figs in this unit because the data at light speed or near light speed is more interesting if we carry a few extra sig figs. If you didn't put the units, I would take a half mark off. I would give, yeah. Yep. I would give you 1 mark for that, half mark for that, half mark for the answer. Number 4 is worded poorly. It says a 45-meter-long asteroid is shot past a stationary space station. Okay, the space station is not moving. The asteroid is. So is the space station going to see the asteroid longer or shorter? Shorter, which means, you know what? This question is asking me to find the relativistic length. That must mean that L0 is 45. I had to make you think about it. I worded it a little more complicatedly. V is 0.98c. So we're going to have this, again, L equals L0 times the square root, 45 times the square root of 1 minus 0.98c over c all squared. Do you see? Do you see? Do you see? Now, here I've given you the speed as a percentage of light. At least once on the test, I will give you the speed in meters per second, and you'll have to put the 3 times 10 to the 8th in the bottom. Sometimes the 10 to the 8ths will cancel. If not, you'll just have to crunch it on your calculator. But here I can go 45, clear. 45 square root bracket 1 minus 0.98. Don't forget the squared. Wow, 8.95? Is that right? Same as before. 1 mark, half mark, half mark. A rock is accelerated to a speed of 0.99 c. What would the mass of the rock be at this speed? I guess they're asking me to find the relativistic mass. This must be m0. V is 0.99 c. I think it's m0 divided by the square root thing. Is that correct? I'm going from memory here. It's 65 divided by the square root of 1 minus 0.99 c over c all squared, and the c cancels. So it's going to be 65 divided by square root bracket 1 minus 0.99. Don't forget the squared. Wow, you get 461, 460.8. I'll go 461. And the units there, I guess, would be kilograms. The Starship Enterprise passes you at a speed of 0.98 c. You measure its length to be 144 meters. How long is the Enterprise at rest? Shane, what's this question asking me to find? Shouldn't you be looking at your quiz right now to figure it out? Yeah, okay. So it wants me to find L0. I guess L, the relativistic length, is 144. V is 0.98 c. I got to get the L0 by itself. Correct me if I'm wrong. Is L0 going to be L divided by the square root thingy? I think. Yeah. So it's going to be 144 divided by the square root of 1 minus, in brackets, 0.98 c over c all squared. Do you see? Do you see? So it's going to be 144. Now, I know at rest it should be longer. So if I got an answer shorter, that would tell me I've messed up. I've mixed up my L's and my L0s or something like that. Square root button, bracket, 1 minus 0.98 squared, close bracket. And I get 723.6 or 724 meters. Now, I know what you're all wondering. Mr. Dewick, is that the Enterprise A, the Enterprise B, the Enterprise C, or the Enterprise D? That's a great question. This is the Enterprise D, not the A or B or C. But if you do look up the Wikipedia page, you will find that is the correct length. No other Star Trek nerds here? Oh, man. Disappointed. You were wondering, right? Which Enterprise are we talking about, Mr. Dewick? By the way, would the people on the Enterprise notice that their ship was all short and stubby? Why not? How fast is the ship moving relative to them? 0. So they won't notice any difference. Again, if we had Superman eyes and could see inside the ship, we would see them all moving slowly relative to us who were at rest relative to the ship. Would the people on board the spaceship, could they tell that they were moving slowly, that time was ticking slower for them? Why not? Because relative to them, they're at rest. They won't notice any different. Even the electrons and all the neural processes, everything is going to be flowing at the same time as the ship is experiencing. They will notice no difference. And of course they won't, because Einstein's first postulate was, if you're going at a constant speed, the laws of physics are the same. You can't tell the difference between going at a constant speed and going at rest. There's no way to tell. A friend borrows your red spaceship Ferrari model X119, which is capable of traveling at 0.95 c. Boy, you better trust that friend with this. The Ferrari is measured to be 5.6 meters high and 18 meters long. I kind of imagined that it would look like this, where that was 5.6 and that was 18. They want me to find, I think, L. So L0, well, if the spaceship is traveling that way, or this way, it doesn't matter. Which length is going to change, the 5.6 or the 18? So L0 is going to be the 18, not the 5.6, where V is 0.95 C. So I said, okay, I'm going to use L equals L0 times the square root function. It's going to be 18 times the square root of 1 minus 0.95 C over C all squared. 18 times 1 minus 0.95. Don't forget the, Mr. Dewick made a typo. Don't forget the squared and put the square root in brackets. I got 5.62. This one is just kind of an interesting answer to me because instead of being 18 by 5.6, now it's basically 5.6 by 5.6. This would almost look like a square spaceship as it went past you. It would no longer look like it had a length and a height. It would look pretty square and stubby. Again, 1 mark, half mark, half mark. Ooh. Is B asking me to find T or T0? How do you know? He's on the spaceship, right? Okay, so this is asking me to find time on board the spaceship. So I guess time back on Earth was 5 hours. It's still 0.95 C, so it's going to be T0 equals, T times the square root function. It's going to be 5 times the square root of 1 minus 0.95 C over C all squared. Do you see? Do you see? You know what I did? I was clever. I just backspaced and I noticed it's exactly the same thing, but instead of an 18, I'll just put a 5 there. I deleted that. Is it 1.56? Is that 1 hour and 56 minutes? Okay, if you said 1 hour, 56 minutes, I would take a half mark off. This is a little more than an hour and a half, right? Because 0.5 of an hour is 30 minutes. This is a little more than 1 hour and 30 minutes. But every so often, especially when the decimal is close to a 60, to a 60, I see kids for some reason tempted to write that as minutes. Our time system is stupid. It's not base 10, it's base 60. Which is dumb. I would change that if I could. And that was hours. Was it 5.6? Did I round off properly? Yeah, I did. I should remove this, where it says this is tough. This used to be tough because I used to make the kids get the V out themselves. I didn't give them those bottom 3 equations on your green sheet. I used to not give those. I would make the kids get the V by itself from the original equations. Now it's way more plug and chug. It wants me to find the speed. I think M0 is 2, M is 4. Ethan, can you read me the V equation that has M's in it? I know it's V equals C. I know there's a square root. I know there's a 1. I know there's a minus. I don't know whether M0 or M is on top. Okay. So it's going to be, now, this question I would not allow on a test because I didn't tell you whether I want this as a percentage of C or in meters per second. So I'll take both. If you left it as a percentage of C, on the test, I will be very clear. There's going to be at least one question where I say leave it as a percentage of C. I'll show you how to do that right now. I would just go the square root of 1 minus 2 over 4 all squared. I would just type the square root part, square root of 1 minus bracket 2 times, Mr. Dewick, divided by 4. Squared, close bracket. The square root works out to 0.866. So if you said 0.866 of C or 86.6%, I would have to give you 2 out of 2 because this question wasn't clear. If you entered the C value, what's C as a number? Yeah, it's really 2.9979, but it's close enough to 3 that we're going to use that. So you would just multiply that by 3 times 10 to the 8th. If you gave it to me in meters per second, I think a good place to round off would be right by the 8 because there's a 0 there. So I'm going to write it in scientific notation, 2.598 times 10 to the 8th meters per second. I would take either of those because this question didn't specify. On the test, there will be at least one question where I ask for an answer in meters per second. There will be at least one question where I ask for an answer as a percentage of C. Okay? And I would again go 1 mark, half mark, and then a half mark for whichever one of those you went with. I like number 9, I like number 9, I like number 9. Number 9 is a nice question. A certain star is 40 light years away. How long would it take a spaceship traveling to reach the star as measured by stationary observers? Now we're stationary, so this is not time on board. This is T. In fact, Nick, we're stationary. We haven't launched anything. We're just going to use our standard D equals VT plus a half A. Oh, sorry, what's A in this unit? Because Einstein didn't know how to deal with it yet. 0. So I'm just going to use this. That must mean they gave me a distance. They did 40 light years. That must mean they gave me a speed. They did 0.995 c. So if I want to get the T by itself, it's going to be D over V. It's going to be 40 light years divided by 0.995 c. The c's cancel. I get an answer in years. Relative to the Earth, this mission is going to take 40.2 years. You know what? We're going so close to the speed of light. We're almost traveling at the speed of light. It takes light 40 years. It takes us 40.2 years. And I'll store this on my calculator as well. As measured by observers on the spaceship. Ooh, okay. Alisher, what's this asking me to find? As measured by observers on the spaceship. Which time is that one? Time 0 on board. So we just found T. Now we're going to find time on board the spaceship. And now we have a spaceship that is moving near the speed of light relative to the Earth. We have 2 objects moving. In A, only the Earth was sitting there. In B, now the spaceship is moving. Now we're going to see some time dilation. I think T0 is going to be T divided by the square root function. Is that correct? No, times the square root function. Times the square root function. I think. Is that better? I hope. Yeah. Going from memory here, and all these equations get mixed up in my brain. So it's going to be 40.2. I'm going to use my answer button. Times the square root of 1 minus 0.995 c over c all squared. Do you see? Do you see? Do you see? So I'm going to go answer button times the square root of 1 minus 0.995. Don't forget the square. Will the spaceship experience more than 40.2 years or less than 40.2 years? Yes. So I already know I better get an answer that's smaller. If I got an answer that was bigger, I would know, oh, I've mixed up T and T0. They're only going to experience 4.015. I'm going to write 4.02. If you went 4.015, I'm okay with that. If you went 4.0, I'm okay with that. But I'm going to store this on my calculator as well. Because C says, what's the distance traveled according to the observed? Oh, sorry. I forgot to do my marks breakdown here, didn't I? So for 2 marks, I would give you 1 mark for that, half mark for that, half mark for the answer, 1 mark for that, half mark for that, half mark for the answer. For C, there's 2 ways I can do this. One is I can do the distance relative to the spaceship if the spaceship is moving through the universe. So the spaceship would say, hey, we are moving at a V times a T, although our T is T0. Relative to the Earth, we're moving at 0.995 c, and the time that we experience is 4.02. I'm going to use my answer button. So if I go 0.995 c times answer button. The spaceship only travels 3.99, you could say 4 light years. Or you could do this. You could say, as far as the spaceship is concerned, it's at rest and space itself is moving past it. So the spaceship would say, well, the original length at rest was 40. We're moving at 1 minus 0.995 c over, we're moving at 99.5% of the speed of light. If I go 40 times the square root of 1 minus 0.995, don't forget the squared, I get same answer. So either of those approaches are just fine. The second approach explains why the spaceship measures the distance to be shorter, because space-time itself is compressed in their direction of travel. Is that all right? So either 1 mark, half mark, or 1 mark, half mark, half mark. Can you give yourself a score, please, out of 26, please?